We are almost at the end of our test, unit test 3 on quadratic functions. This is question number 15. I realize that I haven't really introduced any of the questions on linear and quadratic systems, so I've added 3 more questions after this. They are based on linear and quadratic functions, so also go through them after doing this. So once you read this problem, I'd like you to pause the video, answer the questions, and then look into my suggestion. But don't forget to go further with 3 more questions on linear and quadratic functions. This is question based on application of quadratic function. The question here is, determine the y-intercept of the quadratic function which has following characteristics. A. X equals to minus 2 is the equation of axis of symmetry. X equals to minus 6 is the x-intercept. And y equals to minus 10 is the minimum value, right? So if you look at it carefully, you get axis of symmetry here, right? And the minimum value. So that actually gives you the vertex. Do you see that? This is the vertex, because vertex, which is a minimum value, will be on the axis of symmetry. Now since you are given the minimum value, that means the function opens upwards. So we can kind of sketch a function like this. And here what we know is 1, axis of symmetry, and the equation for this is x equals to minus 2. And the minimum value is minus 10. Therefore this value is actually the vertex, which is minus 2 minus 10. And now we also know here that x equals to minus 6 is the x-intercept. That means if I draw my axis like this kind of, then this is on x-axis minus 6. Do you understand? So that is a kind of figure, and of course when minus 2 is on the left side, my y-axis will be kind of like this. Do you understand? And now we need to find the y-intercept. That means we are interested in finding this particular y point. We don't know where it is. So that is what we are interested in finding. So that is how the question is. Now let's try to find first the equation of the parabola. Once we find the equation of the parabola, then we can always substitute 0 and get the value of y-intercept. Now since we know the vertex, vertex form is the best place to start. So we go y equals to a times x minus p whole square plus q. Now vertex is minus 2 minus 10. So p we can write down as x plus 2 whole square minus 10. So that is using the vertex minus 2 minus 10. Now to find the value of a, we can use the x-intercept, right? So x-intercept is minus 6, 0. So we'll plug 0 for y and minus 6 plus 2 whole square minus 10. So that gives us, we'll bring 10 on this side. So 10 equals to a times, and this is minus 6 plus 2 is 4, minus 4, and square of minus 4 is 16. So from here, 10 over 16 is the value for a, which is as good as, we'll simplify this, divide by 2, and we get 5 over 4. So a is 5 over 4. With this, we can write down our equation, which is y equals to 5 over 4 x plus 2 whole square minus 10. Now what we need to do is to find y-intercept, right? So don't forget, y-intercept is still pending. To find y-intercept, what we need to do is to plug in 0 for x and find the value of y. So we get y equals to 5 over 4, 0 plus 2 whole square minus 10. And that gives us 5 over 4, 2 square is 4, minus 10, and 4 and 4 cancel, we get 5 minus 10, and so we get y-intercept as minus 5. Do you see? So this point which we wanted to find is the y-intercept, and that point for us is indeed minus 5. So we have this point at, I should say, 0 for x value and minus 5 for y. Correct? Now we can write down our answer, and that is y-intercept is at y equals to minus 5, right? So that is the y-intercept for this. I hope with this you have understood quadratic functions, and Unit 3 is absolutely clear to you. Now, we have not included questions on linear and quadratic system. So I have 3 more questions to go on linear and quadratic system. So please go through them also to really cover Unit 3 in all aspects. Thank you and all the best for your exam.